The next fillet that we want to create is the fillet around the base of the spoke where it goes into the center hub. But before we do that, there's a few things that we need to sort out. First thing is the color of that spoke means that it's very difficult to see selected objects. So I'm going to change the color to blue. And then we're going to do a bit of tidying up. So there's some layers, for example, bolt hole, which has got nothing in it. The easiest way to get rid of those is to go into Layers, Delete, Unused Layers, and that just gets rid of anything that isn't being currently used and we don't need. Now what we want to do is delete some of this geometry. Now we can delete these instances quite easily in places. For example, this rim here. I can just go around and pick each instant as an object and then press delete, and that's fine. But there are some that are a bit tricky. And I'm going to try and explain why. So this one here, we know this is a group, so again I could go and delete those. But let's have a look in the SPD window with that selected. And this will hopefully explain why there's a problem with some of them. So that's the node, that's that group that we've just selected. And if we zoom out a little bit, and then I'll go and pick nothing, and I pick object again. If I pick these 4 boxes here, so that one's the master, that one's a copy, that's a copy, that's a copy, and that's a copy. So those are the instances, and that's the original master copy. So we could actually pick those in the SPD window and delete them, much like we did when we picked them as an object in the viewing area. So that's got rid of the copies. But some of this geometry doesn't work quite like that. So if I try and pick that fillet, for example, you can see it's highlighted every single copy here. So let's go and press Alt L here to find out why. So that is all. What we're doing there is picking one node which contains all of this geometry. So let's have a look at this. You can see that here we've got some nodes here which all seem to be related to each other. So there seems to be 3 groups here. So let's go and pick an object. So that one there is that fillet there. It's been mirrored across visually across there. Let's pick the next object. So you can see that's a copy of that fillet, and another copy which is down here, and another one and another one. So those are our copies. So they're down at this level. So we could actually delete them here. That's one way of doing them. And you'll see the same structure here where we can pick all of these. And those are all the copies of those fillets. So the original master isn't selected and won't get deleted. So we could press delete and delete all of those. That's one way of doing that. The other way we could do this, so if you don't like that method because it's a bit abstract, the other way we can do it is we just pick all of the objects here and we turn our instances into real objects. So if we go Edit, Expand Instances, that will actually make real objects of those. Now if we pick Surface here, for example, drag a window around there, you can see it's picked all of those objects, but it's not picking the master one. So when we say Delete Active, it's only getting rid of the objects that we've picked. So that's another way of doing it if you don't like the SPD window. Now the bits in the center, these were grouped together, so we can get rid of those copies. We don't need that one either. And then we'll just get rid of the rest of these bits and pieces that we don't need. In some ways the SPD is a cleaner way of getting rid of this geometry, but this is a perfectly valid way as well. So that's just left us with the geometry that we need. In the spoke F layer we can take symmetry off so that we don't have to see the other side. And one other thing that we need to do, apart from getting rid of the rear of the spoke, because we don't need to look at that at the minute, is this geometry here isn't in a layer at all. So what we need to do is create another layer. So we'll call this rim front, for example, and I'll move that along. So I'm using the middle mouse button there to move it along next to rim, and we're just going to put that geometry in there, just out of the way. and turn that off. So the only thing that we're interested in is this area. And now we're going to just hide stuff that we don't need. We'll keep it on the same center layer, but we just want to hide that. So we can say object display invisible, get rid of that. And there's some curves in there as well. So let's just get rid of all the curves. We'll make those invisible as well. And there we are in the situation where we've now got the essential geometry that we need, ready for filleting. The next thing we want to do is to fillet this area. So we should start off by just throwing a fillet in, and so we're going to use the surface fillet function with a chordal fillet, G2 continuous. Take explicit control off and Bezier surfaces off, and we're just going to pick these surfaces and see what happens. And let's put extend on the start end there. So you can see that's not a great result. It doesn't match here. Matches all the way around here, but it's full of surfaces and we've got lots and lots of CVs to deal with. So one thing we can do is we could try putting Bezier on, see if that helps. Sometimes it does. And that's actually giving us even more surfaces, so we don't want that. So the solution may be to use explicit control. Now you can see that that's not very good at all, and that's because we've got degree 2, so we obviously need to increase the degree. Let's increase it to degree 7, see if we get anything better, and it really looks bad around this corner. You can see there's a real problem on this edge as well, even without the continuity errors, in that suddenly goes off at a funny angle. Doesn't look very nice at all. And the problem all originates from this corner. So the ideal is that if we just take the shading off for a minute, this edge here needs to blend in to here. So instead of having this edge coming off at an angle, this should be flowing into that edge. And if we can do that, then we're going to get a much better result. On this side, it's not so much of a problem because it's almost at 90 degrees anyway in this area. So this is clearly not the solution. So let's undo all. And what we'll do instead is we'll do it in pairs of surfaces. So we'll pick those two surfaces there and then create that. And that looks a much nicer result there. We may be able to drop the degree down a bit. Now we can drop it down, we can even drop it down to degree 2, but the problem is we've got to also make sure it's matched across the symmetry plane here. So giving us only degree 2 only gives us 3 CVs. That middle row is likely to change if we match it across the center line. So let's just increase the degree to say 4. It's more likely to succeed. So let's go into the symmetry align, and first of all we need to put this surface on the appropriate layer. So I'm going to put that on the front spoke layer because we know that the symmetry plane there is the plane that we want. So let's switch the symmetry off there. Now we want to match that in symmetry, so we need to use the symmetry align tool. And we've maintained the continuity here, and we've got tangent continuity across that symmetry plane now, which is great. Now we might want to extend that a little bit, so we have extrapolate merge on. Again, it's telling me it's deleting history. That's not a problem. Do watch out for these curve on surface, because you can just about make out that that curve on surface stops there. It hasn't moved, and this could cause us a problem later on. So what we should do is delete it at this stage, just to make sure that we don't have a problem. So that's okay on that side. On this side, we need to extend this surface out, because at the moment, if we shade that back up again, it's coming short. So let's see if we can just extend that. Now, depending on how the fillet was built in the middle, we may or may not maintain that hole. You might find that the curves on surfaces stretch, but in this case not, so that's great news. So we've now got a better situation where we can put a fillet between those two surfaces. Something else that we can do is to untrim this surface. So let's go into untrim, And we want to maintain this curve on surface here, so make sure that we've got delete curves on surface off, but we want to untrim all of the trimming on that surface. So we've now got that untrimmed, and that just means that we've got more surface to build a fillet off. So we go into surface fillet again, same parameters, and we create that. So we've only got degree 4 at the moment, so we're going to increase that a little bit. Let's make it degree 7. Now that's not matching at the moment, so what we'll try is Bezier surfaces, because we know that sometimes works, and in fact it has worked on that side but not on this side. We can also try taking the extend off, because that sometimes isn't good, so that's much better. But we want to extend on this end. We can go back to the menu and make that extend there, or you can actually click on the text there and it will extend it, so it toggles through all of the different options: edge align, connect, default, or extend. So that's created us a nice result. There's one problem with this, that if we rotate this around a bit and zoom in, when we come to do this corner, we've got this fillet edge here and this fillet edge up here, and so what that means is that the edge of the fillet as it goes around the corner is going to S. So this may not be the best way to create this junction. So we're going to look at another way of creating this, and that's to use the symmetry fillet. So first of all, let's get rid of this surface, and we'll get rid of these curves on surface here. So we don't want to leave curves on surface lying around. They can be quite difficult to find. So what we're going to do instead is we're going to use symmetric fillet, and what this requires is we need to create one edge which will be around this area, which will be a constant offset to this surface here. So the starting point is to take this top surface, and then we're going to offset that by a certain amount. So we don't know how much that might be. So if we press the space bar, we actually get the surface appearing, and we've got the distance in here, so we can adjust that. It's not very easy to adjust that, you have to put in numbers really to adjust it finely. So to fine tune that, we're just going to measure from the edge of this fillet, so we're going to use curve to surface measurement here. So we're going to measure from the edge of that fillet there to this patch, and if we take the shading off again, you can see it says it's about 1.3 mil. So we need to go and offset that surface slightly from where it is currently. So if you go into the query edit tool, that lets you pick this surface which has got history on it, and we can then adjust it. So we want to adjust it by about 1 millimeter. And if you want to be a bit more precise about that, you could make it 8.7. But we'll never get quite spot on that fillet. We're going to throw that fillet away and reconstruct it, but that's as close as we need to be. So now what we want to do is we want to get rid of that surface, get rid of that fillet, because we're going to build a new one. We also want to make sure that we clean up the curves on surface after us, and we want to make sure also, if we go into hardware shade, on this edge, because this is going to form a curve which is the intersect of this surface and this surface, that it's important that curve is tangent into the symmetry plane. So once more, we'll pick that surface and assign it to the spoke F layer, which we know has got the symmetry on it, the correct symmetry plane, and we can do a symmetry align on that surface, which is the case now, and then we'll extend this other end so that we've got that crashing through all of those surfaces. So it needs to intersect all of these surfaces. Now we're going to create an intersect between that and all of the surfaces up here. So we're going and find intersect, and we only need the intersect on the first surfaces, in other words these ones. We don't need it on this surface here, that's purely for construction. So if we press go, pick a surface, pick the space bar, pick the other surface, and we've created the curve on surface. Let's take the shading off. So there's our curve on surface. We can do the same thing on the next one. So we're going to pick that fillet there, press the space bar, pick that surface. There's our curve on surface. Then we're going to do another one. So we're going to pick that one, space bar, pick that surface. So we've got all the curves on surface now. This surface we no longer need, but we'll keep it. We'll just put it in the construction layer there. Now we need to go and start filleting that. So we're going to, rather than use surface fillet, we're going to use symmetric fillet. Again, G2 continuity on both sides, form factor of 1. We'll take explicit control off and Bezier surfaces off to start with. Now we need to pick, it says select surface curves on first set of surfaces, so it's this curve here. And then once we've picked all those, we can accept that, and we pick the surface that we want to fillet to, which is that one, and that's created this. Usually we want to take automatic off and make sure it's just curves on surface, which is what we've got here. And we've got extend, which is good because we want that to go a bit further in this direction. So the next one is going to be this one. So that's the first set of surfaces, the second set of surfaces, and there's our fillet. In this case, we're going to put explicit on because that was a 2-span surface, and we'll see if we can drop the degree, and it doesn't look like we can, so we'll keep that at degree 6. Now we're going to trim back this surface here. We're going to trim it back, but we're also going to do a trim convert version of that trimmed surface. And the reason for doing that is that the trim convert version we can use for construction, and the original trim part we'll keep for our final model, so that we can always get back to this original fillet if we want to. So let's go into trim. So this is a technique that I use on a lot of fillets. So on this one we're going to just trim it. We've already got a curve on surface, so we just need to pick that fillet and then trim it, and then we can do a trim convert, but we've got to remember to keep the original. So we've got to keep the original on there. We'll do a trim convert on there. Now what we're interested in is the accuracy of this to the trimmed version. So we've got the trimmed version and the trim convert version on top of each other now. So we can, in here we can say show edge deviations. So that tells us what the edge deviation is here. And it says 0.0027. We're working to a position tolerance of 0.001, so that's outside tolerance. So what we've got to do is increase the degree going around this way. First thing I'm going to do is put auto update on, and then as I increase the degree, so let's try 6, we can see what the deviation is. Now it's 3 zeros 1, and that's perfectly fine. So we'll accept that result. And we can also get rid of all of those locators, we don't need those. And what we'll do is we'll just put that surface there into our construct layer there. So this surface here, this trim convert surface, is the one we're going to use for construction purposes. The one we've just put in the construct layer for the time being is the trimmed version, and that's the one that we want to incorporate into our final model. So this trim convert version we'll throw away eventually. Now we want to create this corner fillet. So the first step in that is to create a blend curve. So I'm going to create a blend curve degree 5 because we want it G2 continuous, and on this edge I'm going to actually pick, so we've got the choice of either a curve on surface or the fillet itself. So I'm going to pick the fillet and just show you something here. So as we drag that around, you can see it not only goes on the edge but it also goes on the surface. So you have to be very careful that you move the cursor below that line so that we don't end up in the middle of the surface, or even worse, just slightly off the edge where you can't even notice there's a problem. So we move that around to wherever we want to. On this end, what I'm going to do is pick the curve on surface instead and just show you the difference. So with curve on surface, it doesn't matter where I move the cursor, it's not going to go up that surface. So in a way, picking curve on surface is a safer option, or if there was a curve there, that would be even better. And you can see we haven't got the G2 continuity that we wanted, even though we've specified it here. So if we go into edit, what we have to do is snap that tangency to that edge there. And we'll do the same thing on here. So we're just picking that blend point and then snapping the tangency and the curvature into the edge of that surface there. So we've got our degree 5 curve here, and we need degree 5 at least to get G2 continuity, because these three CVs here control the G2 continuity this end, and these three CVs here control it this way. And the beauty of the blend curve is that we can pick that end point, pick it twice so that it highlights in white, and then we can slide that up and down however we want to, which is great. So now what we want to do is create a planar surface between the tangent end of this end here, of this edge, and this point. So the tangent end condition of this edge is defined by these two CVs here. So one method of creating this surface that we want, so we're going to intersect this fillet with this surface, and then we can cut the fillet back. So one way of creating that end tangent condition is to use a straight line. So we're going to have a degree 1 straight line here, and we're going to use control to snap to the end CV, and then control again to snap to that CV. So we've got a straight line there which is actually the same angle as the end tangent of that edge. Now if we go into the X-form function and use slide, we can grab that top CV and just pull it down, so that we've now got a line coming down in this direction. So that's a tangent line off this edge. Now what we want to do is we want to create another line. So I'm going to use blend because it's got history on, and I'm going to put in a degree 1 blend curve. So this is a straight line, and we're going to slide it down this line using Control and Alt. Press go first, slide it down there, and then I'm going to slide it down this curve here. I'm sliding it just to make sure that we're getting exactly to the end there. And that because I've used the blend curve there, that's going to have history on it. So if we were to go and pick that blend point there on the original corner, and then we want to move that around, so we go into Edit and pick it so it's now white, we can now slide that up and down, and you can see the line connected to it is also changing. So we've got history on that line there. Now we want to create our planar surface, so we've got the two lines here and here that we're going to use, and we're going to use the monorail. In other words, sometimes it's bi-rail if we've got two rail curves, but in this case we want one rail curve. So we've got one rail curve, one generation curve, doesn't matter which way around you pick them, and there's our surface. Now if we shade that up, that looks like that. And again, at any time we can go and pick that blend point, so it's that one there, and go and edit it, pick it and move it, slide it up and down, and you can see the surface updates. And what we're after on this end is trying to get the intersect to come in at 90 degrees to this edge, or roughly thereabouts. If it's 80 degrees, it doesn't matter. We don't have to measure it. We just want to. We don't want it down here. That's going to give us a poor condition, and we don't want it up here either because it's curving back on itself then. So 90 degrees is the ideal. As long as we're close to it, it's not something that we have to measure accurately. So that surface is now intersecting the fillet. The only problem that we might find with that is that the surface is only just intersecting the fillet. And so let's just take the shading off again. So really we want to scale that up. We want to extend it in all directions. We could go and extend it. A simpler way to do it is if we pick that surface and we go into the Transform tab here. Under the pivot options there, we've got something called center pivot. So what that does is, using center pivot, puts the pivot point right in the middle of the surface. And so now we can go and scale that. So it's going to break the construction history now, but we can scale that up, and we've now got a patch, a surface, which is intersecting that fillet completely. So there's no doubt about that. And what we would then do is we then go into Trim Convert, and we're going to use 3D trimming with intersect on. and we're going to pick the surface that we want to convert, which is that one. Pick the surface that we want to intersect it with, so you can see by the green dots there and the blue line is our curve on surface, so that's successfully creating a curve on surface right across from one edge to the other. And then we pick the area that we want to keep, which is down here. So now we want to do a trim convert on this fillet here to the intersect with this planar surface. So if we go into trim convert, and we're going to use 3D trimming with intersect, we're going to pick the surface that we want to convert, which is that fillet there. We're going to pick the surface that's intersecting it. So by doing that, we've now created a curve on surface. It's got green dots on the end, which means the curve on surface goes completely across from one side to the other, which is exactly what we want. And then we pick this surface in the middle somewhere, and then press the space bar, and that's created us the trim converted surface. We have got keep originals on, which we don't want, so we'll get rid of that. And then if we come out of the menu there and pick nothing, we've got the surface that we wanted. So that's trimmed that one. We'll do a similar thing on the other end. So on this end, I'm just going to show you a slightly different technique. So on this end, we created a line of the two CVs there, which is a perfectly valid way of doing it. Another way we could do it is if we go into duplicate with no rebuild on this edge, and just make sure you've got the edge, because that's another one which can slide around the surface. So just pull the cursor over to the left there, make sure it's on the edge, and then press go. So that's created us a curve. And now if we go into extend, and with this one we want a slightly different selection here. What we want is a linear extension, so in other words create a line off the end, and we don't want merge on. So what this will do is create a line which is separate to the original curve off this end point. So we press go, pick on that curve that we've just rebuilt, and we can slide that line down. So you can see we've created a straight line just like we did over there, just a slightly different method. Which one you choose is completely up to you. And like we did on here, we'll put a straight line blend here. So we go into the blend function there with a degree 1, slide down that end point there, slide around this blend curve here. So we've now got a situation where if we pick the blend on this corner, we can then move it around using edit and pick it once, slide it around to wherever we want it to be. But we don't have to make that decision, of course, until we've got the planar surface in. So it's back into our monorail, one generation curve, one rail curve. We pick that curve, we pick that curve, and there's our surface. And we can shade that up so we can see what it looks like. And that's actually looking in a pretty good position there, but of course we can go and pick that blend point there and then just move that around wherever you want to until your surface is exactly where you want it to be. So that's one consideration, is that line coming in at roughly 90 degrees to the edge. The other thing we want to do is just check that these CVs going around here look reasonable. And by that I mean balanced. So they need to be balanced around, if you imagine a theoretical intersect between the end tangent there and the end tangent there. So you put a line there in your mind and extend it through here, and put a line between those two CVs and extend it to here. There's a theoretical intersect about here. So you always want those three CVs to be on one side of the theoretical intersect and those three CVs to be on the other side, which is what we've got here. Now we want to trim convert this fillet as well. So as before, just to make it clearer, I'll take the shading off. We'll pick that surface. So we want to scale that. So the first thing to do is to go into the transform tab. And of course you could put this on the marking menu, but I've chosen not to do that because it's not standard. So with center pivot on, that creates a pivot right at the center of that surface, and then when we scale it, it scales it in all directions. Of course, we have to break the history to do that. So that's going to completely create us a complete intersect from one side to the other, which is exactly what we want. And again, we'll go back into trim convert, and we're going to pick the surface that we want to trim convert, which is that one, the surface that we want to trim it to, which is that one, and there's our curve on surface in blue. Our green dots at the end show that the curve on surface exactly reaches each edge, and then we pick the point, the area that we want to keep, press the space bar, come out of the function, pick nothing, and we've got the surface that we need. And at this point we can now tidy up a bit. You could delete those, or you can, as we normally do, just assign it to the construction layer there, just to get it out of the way. And finally, let's put the shading on. So we've now got the hole that we want to create our corner fillet in. Before we go any further, there's one thing that we need to clean up that would catch us out later on if we weren't careful, and that's that when we did a trim convert on these surfaces here, we left behind a curve on surface which actually extends to the full length of that surface. So let's just see that. So you've got a curve on surface there, and if we zoom into that, you can see it actually extends to where it was originally, and we don't want that. It's got to stop at that point, otherwise we're going to be in trouble. And the same on this side, it actually extends all the way down to here. So we need to pick those and then delete them, and then we can regenerate those by doing a project. So project curve on surface normal. So we're going to pick the surface, spacebar, projecting curve, that one, and then hit the spacebar again, and that's created us the curves on surface. I'm going to take history off because that's another thing that can cause trouble later on. Now we're going to put in a surface in this corner, and we're simply going to use square. It's a great way of filling in holes. So we're going to pick in that edge, that one. Make sure we pick the edges, not the curves, except on this, in this case where we've got to pick that curve. And we'll put the CVs on. So we're just matched in position on 3 edges at the moment, and presumably in position on that edge. But we want some higher level continuity. So here we can specify on the 4 edges, so 1, 2, 3, 4. Remember, that's the order in which we pick them. That's 1, 2, 3 and 4. You can just make out those numbers. So on those first 3 edges we need G2, and the last edge we just want G0, just position. And you can see that creates a truly horrible result because it's increased the degree, it's increased the spans, it's just not very nice. So we need to override that with explicit control, and we want degree 5 in this direction, and in this direction we'd want at least degree 5, but in this case, because this fillet up here is now degree 6, we want degree 6 going around that way, which is in fact what we've got. The other thing you notice with this is that where it joins up to these fillets, the holes are coming off at a funny angle, and that's because we haven't got collinear on. Here we can specify on each of those boundaries 1, 2, 3 and 4 whether we want collinear or not. In other words, do we want those holes there, those CV holes, to form a straight line into the tangent of the adjacent surface, which of course we do on those 3 there. So that's telling us that we've passed in G2 continuity there, and we failed there, but that does mean that we've achieved G1 continuity. On this one we can't compare it with the surface at the moment because we're just comparing it with a curve and not the surface. Again, we want to make sure history is off so that we don't get into problems later on. So we'll come out of there. Now we want to align this edge into that surface. So in fact we do need to go back into the align function with G2 on, and we're going to align that square so that that's a square surface there. Uses the square function rather than actually being square, and we need to match that into this surface. Now if we'd left edge on, we get something truly horrible, because it's trying to match into that edge. What we need is project. So that's what that's doing, is it's creating a curve on surface onto that surface, and it's doing it normal to the surface, and therefore it gives it something to align to. Otherwise it's got nothing to align to. And so now we've got curvature matching, or G2 continuity, on 3 edges. The last edge we want is this one here. Now when that says, the fact that it says P has failed, position has failed, sometimes means that as a result of matching this way in terms of these lines, these holes being linear here, it's pulled the edge of the corner away from this fillet. It's so small you can't see it, but that's often the case. So the solution there, rather than matching this surface into that one, can be to match this one into that one. So let's try that one. So we're going to match that one, and we only want G0, and we'll match it into the center there. Now that's not worked, which might be a bit surprising, but we've got project on still. So let's try edge, and that's much better. So project would be trying to put a curve on surface there. We should just check whether there is a curve on surface, but there isn't. That's fine. We need to make sure that, having matched that in position there, that we haven't lost G2 continuity on those 2 sides there. So let's go into our SurfCon, which is on G2, go and pick those, and those are fine. So what we should do is have a look at this one and see whether maybe that's higher than position now, maybe it's tangency. What we can do there, one method of doing this, is to go and pick the locator, and then we can go into the information window, and you can change in the information window. You can say you want to go from positional to tangent. You can see that's failed, and ultimately curvature, which of course is of no use at the moment because we're failing in terms of tangency. But we're getting closer. It's always an iterative process, this alignment in these corners. So we're going to now align, and we're going to align this corner into the fillet. So the other way around now. And we're going to try and align it in G1, see if we can do that. So we've achieved G1. We've broken the curvature here. Let's try G2 and see what that does. So that's really not good. So we'll just leave it with G1 because that's not bad. It's getting close, but we've just lost it slightly here. And we'll try matching this edge now. So we pick nothing, pick that edge. Now before we did a project on that edge, or onto the surface rather, but we've got to use edge this time. If we use project, we're going to end up with 2 curves on surface, and that starts to cause problems which are really difficult to understand what's going on when you've got 2 curves on surface in an area like that. So we're going to match it in this sense, in this area, into the curve on surface. So we've got it in tangency. Let's try and up it to G2. That's successful. So we've got G2 on 3 edges now, tangency on that edge. I'm not so bothered about the tangency only at that point, because usually that's less important than the G2 continuity on the edges of the fillets. That's more important than achieving G2 on these ends. So at that point I'm going to save the model, because it's always worth saving at a critical moment. The other thing that we need to do is look at the patterns of these CVs, because at the moment they're not particularly good. You can see they wobble around a bit. So what we need to do is go through each one of these and put them on a plane, and the plane will be using that CV and that CV to create our plane. So if we go into plane here and we want the 3-point option and we press go, and then what we're going to do is we're going to snap to these CVs. So when you're snapping to CVs, it's best to be somewhere away from them, and then you can clearly see it snapped. If you're too close to them, sometimes it doesn't seem to pick up the CV, it seems to pick up the surface instead. So if we press Control and pick, it's found the first point on that CV, second point on that CV, and this one I'm moving away from it slightly, there's the third point. Now we hit the space bar, so that's set up the plane, and if we want to see the plane, we can toggle the grid on so that we're actually in this new plane. So it's actually gone into that new plane. And what we need to do is then go into the right hand view of that plane. And so from this angle you can see the grid is going right through that area. And what we want to do is move these CVs up onto that same plane, and then they'll all be beautifully planar in that area. And we're going to do the same thing on all of these. So we can do that with planarized hull, view based. Very important that here we use closest boundary. So what that will do is when I pick this hull here, it's going to move these CVs along the tangent lines to the closest boundary. If you don't do that, well, I'll show you what happens. If I put on adaptive, say, and pick there, it doesn't do it, and often you'll break the tangency. In that case it didn't, but that was just sheer luck, I think. So let's undo that. So you'd want closest boundary on. And then we go to the next one. So we just have to go, it's something that you just get used to doing methodically. Pick that one, pick that one. I'm picking away from the CVs there. There's our plane. Hit the space bar, pick on the right view, and you can see that that's where the plane is. And then we're going to use planarized hull, and that's aligned it there. So we do the other ones. So it's creating a plane on that CV, and that CV. Press the space bar, right view, planarize. You can see that's almost there anyway. Of course you can do this by eye, but you've really got to then zoom in with a non-proportional zoom window to be able to judge it closely enough. So again, a plane snapping to those CVs and that end one, space bar, right view, and there we've got them. So the fact that we've slid those CVs along those end tangents means that we haven't lost the tangency or the curvature in that case. There are times when that might happen, that it might go off, in which case you've just got to align it again. But that's actually looking quite nice. I'm going to go and switch the grid off. Now, you'd think that that was it, but in fact there's a lot more tidying up to do. Because we've got degree 6 going this way rather than degree 5, which we would have sometimes. If that hadn't have to be degree 6, then we'd have only had the 6 CVs going around this way, but we've got an additional one in the middle, and you can see that's dropped down a little bit. So you just have to rotate the view around, use X form with slide on, and then you just pick that point. Make sure you slide it along the end tangent, not that one, because then you're less likely to cause a problem in terms of the continuity to the edge. So I'm trying to get that line through there looking as neat as we can, and then we can do the same thing on that one, something like that. If you feel that that one's a bit high as well, you might want to pull that down. So that's from that angle. Then as we rotate it around, we want to look at these 3 holes, so that one there, that one there, and that one there. And if you look in it's again the middle one's the real problem one, because it's just undefined where it wants to be. So this one is a bit too far out this way. So what I'm going to do is again move it along the correct tan line. So you use that one, then we're less likely to break the, although there isn't curvature matching on the outside edge at the minute, it's less likely to break it if there was. So we're going to then do this one, and this one's very important that we move along that line there so that we don't break the tangency, although the tangent is broken at the minute, but we'll fix that in a minute. But it's a combination of getting the continuity correct and also the I'm just changing the tumble mode there. Also the continuity and the patterns of CVs are both important, and so you've got to work on one and then the other and go backwards and forwards. So now we need to do a little more alignment. So let's try and align this edge here. So we're aligning to an edge, and it's the curve on surface that we're interested in. We could actually get rid of this curve because we don't really need it, and it saves us having to deselect it every time. So we've now got a really good result because we've got CVs which are all planar going around that way, or mainly planar. If you feel any of them have come off, you can go and switch to that plane, of course. In fact, I think that is planar. It just depends on the angle you look at it from. And those are planar, and that's a planar. And once you're happy with that, and it's all matched in, the only side is that I say is that tangency. We could try once more to match that in curvature, but you won't always get the curvature working, and you can see that that doesn't want to know. In fact, I'm going to revert because it was better before. The other option, the other thing you can try is there's the older align function. Sometimes that's better when you're matching into the ends of things. So let's try that one. Very similar. We pick the surface that we want to change, match it in, and we've got first tangent on. We want collinear rather than default. So that's created that. We go into the control options, put the continuity check on. So we've got the same result that we had before. Let's try and bump it up to curvature. No, again, it's breaking the position. So I think we have to accept the fact that tangency is as good as we can get. If you wanted to try and get that curvature, then what you would have to do is probably manually move the CVs around, or you might have to increase the degree of this corner in this direction. But if we look at it, if we go into the tangency there, pick the locator and go into the information window, and we can change from tangency continuity to curvature continuity. And quite surprisingly here, it is actually curvature continuous. Even though we didn't align it in curvature, we've managed to align it in tangency, and by sheer luck really, it's come out as curvature matched, and that's just a lucky chance there which we'll take advantage of. Fantastic. Okay, so we're now going to do a file save as 1649, and we've got a lot of planes lying around here. There's no real need to keep them once you've got to a point. I mean, you could keep them, and I suppose you could put them on a construction plane. Well, let's do that, shall we? So let's pick construction. So let's just pick the planes, and then I can assign them to that layer. So you've got them there if you want them. Alternatively, you can just delete them. The other thing that we've still got this construction surface in here with all its CVs on it. So we really want to put that in the construction layer now and bring back the surface that we really wanted to keep, which was that original trimmed surface. So we're going to pick that, and then we're going to assign that to the front spoke, and then remove the construction, and we're going to hope that that matches in, because the two were accurate in terms of the deviation between the edges. Then that's actually worked out. The beauty of having that surface in there is that if you ever needed that fillet back, the original fillet, you've still got it. You can see the CVs of it. And then we want to, so having done that, we've done all of the checking of that corner. We're now going to just trim that up. So we've got curves on surface along there, so we can just trim. We've got curves on surface along here, so that should just trim. And then this one here, again, curves on surface all the way along there, so that just trims out there. And we're going to just delete all of the curves that we don't need. And we'll delete all the locators, just get rid of those. And then if we go into control, we can take all of the CVs off. So we say all off, go. And we can assign these surfaces here to the front spoke, and it's probably worth saving again at that point. I like to save every 5 minutes or so, because at least you've got something then you can go back to if all goes wrong. And what we want to do then is just have a look at the quality of that, so we can have a look at hardware shade, which looks quite nice. So what we can do now to assess the quality of that surface is go into Object Display Diagnostic Shading, and we'll just switch on one of the zebra stripe displays there, for example that one. Now that's looking a bit jagged, so what we need to do is make the tolerance really small, and we might as well put in a number 0.0001 for example, and change the tessellator to accurate. And so as we zoom that around, pan it around, move it around, take the edges off with F12, you can see that that's a very nice result. Everything's smoothly transitioning into that corner, and that's because we've got G2 continuity. Of course, if you wanted to go even further, you could have G3 continuity, and then you might get an even better set of zebra stripes.